Hello, am I audible? Hello, am I audible?
Good evening, sir.
Yeah, good
Yes,
evening.
sir.
Okay, so are you able to see my screen?
Yes, sir.
Okay, fine. So hi, good afternoon, good evening. So today we are going to do questions on digital image processing. So I think your background is in computer science, if I'm not wrong. I mean, hello.
Sir, are you talking about me?
Yeah, yeah.
No, sir. Actually, I have background in mathematics
Yes,
and geography.
yes, geography. Okay, okay. But yeah. So have you worked with images like in general images, satellite images or images?
Yes, sir. A little bit in like in my master degree, like I am pursuing masters in geomathematics. So a little bit in second semester, I worked on some satellite images while I had a subject digital image processing there.
Okay, so what kind of things you have learned from that course or from like when you get an image, what kind of operations do you do mostly?
So generally, like in theoretical portion, we learned about some geometrical and radiometric reactions and all. But in practical exercises, we worked something like PC, principal component analysis, and high pass filter, low pass filter, like image enhancement, contrast, stretching, and all.
Okay, so which software you used for that?
So ADAS imaging.
Okay, fine, fine. So let's start from very basic. So what I can show it to you is like, let's say you have this phone. Okay, so you might have taken photos from your phone, isn't it?
Yes, sir,
Okay.
definitely.
So do you like photography?
Yes, sir.
Okay, so yeah. So let's say if your photo is not good and you go and try to edit it. So what kind of thing you do when you edit a photo? So first of all, let me
So
clear
just
this photo which we take through our phones. It's a digital image, as each image is a constituent of small pixels, and then we represent it as a RGB bands. Okay, so now yeah, my point. So when you take photo and do start editing, what kind of things you do in your editor, photo editor, or in mobile also?
So generally in mobile, I often do editing, but if like I can use some filters or uh, making it blurry to hide some regions in background,
Yes.
just like
Okay, okay.
this.
So let's start from the basics. I mean, in that, let's say if I have some photos, uh, let's say I have this photo. Okay, this photo of plane is there. Okay, or yeah, I just take any other photo. So let me find. So let's say we'll go with one photo, which is something like this. Okay, it's kind of photo from nature, and we want to edit that photo.
Sir,
So
is
what
it
you?
Gujarat?
No, it's in from Maharashtra. Yeah. So let's say we have this photo. Okay. So now when you open it in your normal phone, okay, like normal phone or in laptop or anywhere, if you will open that photo and if you just click on edit, there will be a multiple things you will see under this adjustment. Okay, so under adjustment, like first, it is a monochromatic adjustment, which where you will change the light or exposure or contrast, basically everything you do with the light. So which unit Like, uh, like how do we measure light in this photo? I mean, what is the one thing that is representing light?
So digital number,
Yes. So
digital number
digital
values.
numbers, the pixel values, digital numbers, which will show the intensity of light, that how intense that light is. And when we talk about RGB imagery, it will give us the intensity in three different bands, R, G, and B. So here, probably the intensity in green band is high. That's why the image is looking green. Now, let's say if I increase the brightness of this image, okay, or else if I'm decreasing the brightness. So what is happening?
So its digital number values are increasing.
So how it is increasing? Like if I want to say in terms of mathematics, okay, if I want to define it, like what are the things which are happening, then how can I say like what is happening? See, if you have this all the pixels you have, okay, for this image. So when I'm changing brightness, which pixel values are being affected and what kind of operation is happening at the back? Have you think of it? I mean, anytime. Okay, so the thing is, brightness is like you are increasing or decreasing the intensity of the pixel. Okay, so
So
this
just like we
yes,
are shifting our histogram towards the right side.
partially true, but see that is in terms of histogram. But if you see in just forget about the histogram. Okay, so when you apply this brightness, what it will do is it will add some value into your pixels. Like if the pixel value original is 200, it will like, and if you are saying that add 5, then it will add make the value as a 205. Or if the pixel value is 210, then it will make it 250. So basically we are adding something. This operation is addition. Okay, so if I'm increasing the brightness, it means I'm adding more and more. So what will happen, as you told, like our histogram will go towards the right hand side, towards the bright side, and if I do the brightness to decrease, then it will shift towards the left hand side and image will become darker. So that is brightness. Now let's say exposure. So what will happen in exposure now? If I will change exposure to increase or decrease, then what will happen? Now you see, first we'll see the brightness. Let's say brightness like this, it is happening, and this is the less brightness. Now similarly I am doing the exposure. So in this also, like if you see the words, both look similar to each other. Exposure means like how we are exposed to light, and brightness is also some kind of light only. So when we talk mathematically, then what is happening in those two? So both are like increasing the values of your pixel, but brightness is an additive operation, like you add something into your image, whereas exposure is multiplicative operator. So there you multiply something with your image so that the intensity of pixels are increasing. Okay, so
Yes, sir.
one is additive, one is multiplicative. Then we go to contrast. So if I'm increasing the contrast, what is happening now? See, now I'm able to see this water very well, like which is falling as a waterfall. Okay, so the contrast between the green and white color is becoming more and more, and because of that, I am able to see the things very clearly. So, what happens mathematically when you are changing the contrast? Now, let's say if I am reducing the contrast. Okay, so what thing will happen here? So, as name
So
suggests,
divide is
yes,
the division.
no, division will not happen. So, it is kind of histogram stretching. So contrast, what it will do is it will create, like if your black pixel is there, then it will make your black pixel more black, and if white pixel are there, it will make the white pixel more white. Basically, it
Yes,
is
sir. Definitely.
yes,
We stretch the histogram in this way. darker becomes more dark and
Yes, exactly.
brighter becomes more bright.
Exactly. So
But
it's kind of
like you
stretching.
asked mathematically,
So
then this
mathematically
operation
it's
is
a interpolation. It's interpolation. It's a stretching we are doing. So earlier the value might be ranging from 80 to 130. Now that value will range from 0 to 255. Okay, so it's kind of linear interpolation thing we are doing here in contrast. So when I'm saying that black is becoming more black, white is becoming more white, it means that it is trying to make it more contrast. So that we are stretching the histogram or we are like stretching or making it thinner. So basically histogram stretching and thinning is both operation is are like linear interpolation. So it's kind of additive operations. Additive plus multiplicative, both you can say. Then there is a words like highlights and shadows. Now, how these are related is like highlight will focus on only the pixels having the white values or the pixels which are on the right side of the histogram. So it will do the same operation as we are doing in a brightness, but it will only do it for the pixels which are having high pixel values or pixel intensity. So the pixel which are having less values or towards the right left hand side of the histogram, they will not get changed. So how it will get to know about which pixels are more bright or which pixels are less bright? So it will create a distribution of like S curve or any other distribution, and then based on some threshold, it will find out that which pixel, like whether I should focus on the last 10% part or 5% part, and it will apply all the operations similar to brightness in that particular portion only, not to the entire image. Similarly, shadow, if you will increase or decrease, it will focus on the pixels which are black in nature, not to the pixels which are white in nature. And this vintage or this kind of things which you see, then it will affect on the, it's a not a multiplicative or something, it's kind of spatial filter, or you can say it's a spatial operator. So what it will do, it will calculate the distance from the center of image to the edge of the photo, and based on that it will assign the weight, and according to that it will reduce or increase the brightness value of the pixels. Like if the pixel is far away, then the value will become more dark or more bright, and if the pixel is nearby, the value will, so basically it's doing this brightness thing only, but with the weightage brightness. So that weight will be given based on the distance. Okay, so these are the basic operations which we do and the mathematics behind that. Now let's say if you use any filter, so there are multiple filters. So basically every filter has its own thing. Like if once you apply the filter, there will be some kind of matrix or kernel is going through entire image, and it will do all the things like multiplication, subtraction, on whatever it is. So like that they are generate the, basically they have already adjust the value of brightness, contrast, hue, saturation in such a way that if your image is calm, if you have blue and all color, then it you have, if you just apply this filter, it will work out. If you apply this pixel, this filter, then it will work out. So basically, if you see any editing software such as Adobe or any other, then you will see the histogram on the any of the parts. So this is like I just use the web-based photo editor, which is Polar 2.1, and in that I am doing this image editions, or you can say there whatever the I'm changing the colors and also basically let's say if we have this image and histogram of this image, you can see it's like distributed histogram, like all the bands are having the values in different channels. Now when I'm doing exposure, if I'm increasing, then you see this histogram is shifting towards the right hand side as you suggested. So basically it's increasing the pixel value of all pixels with some percent or some addition. Then this gamma value is like it is just shifting the histogram from one part to another part. So basically it's a location where it is moving. So that is gamma. So basically histogram shifting only, but it will shift the entire histogram to left side or right side rather than making it contrast or increasing the values. Then if you increase or decrease the contrast, you can see it will like make red patches more red and black patches more black. So your image, you can see the different like contrast between red and white and black color. And you can see now applying the exposure, so it became on this side. Now see, once we applied the exposure, all the histogram went towards this side. Now if I'm increasing the contrast, now see the histogram is stretching. This black part or the part where the values are less, it is coming on this side, and this side is going on this particular side, right hand side, more right hand side. And similarly, if I decrease the contrast, then it will try to come in center. So basically, this is the like in terms of what happening in terms of histogram, and if you see mathematically, then those operations are happening. So similarly, highlight, shadow, whites, blacks, so they will focus on particular white and black portion of the values. And then you have some other thing also, so tonal curves, and also if you want to see as per this, like if you are interested, then you can increase or decrease the portion like of one or another color, saturation, hues. So that will be like go on to color side, but will not go on to that particular side right now. So these are the like how, and these are the different filters which are on this right hand side. So if you apply these filters, basically ultimately what will happen that it will change the histogram of your image. And basically if you want to make your image more appealing, you have to, it depends on like how you want to make, if you want to make it black and white, or if you want to see more detail, more clear detail. So according to that, what is your requirement, either you have to increase the brightness or contrast or highlights. So another thing is highlights. So highlights will apply the different Laplacian or edge filter, which are like high pass filter, and if you apply those filters, you will be able to see the sharpness in the image very well. And it will see, otherwise, see, basically wherever this things is intersecting or something like two boundaries are there, it will try to highlight those things. So if you want to do image detection and all, so like text detection from this given image and all, then it will become very easy because it will help you to extract the particular letters well. Yeah. So any doubt till this point?
No, sir.
Okay. So now let's say we will start doing it, and basically, let's start it. Okay, so now we will try to solve some questions. Meanwhile, we'll solve some numericals. We'll see mathematically how it is things are being done. And then after we'll try to code the same thing, like if we want to apply a kernel or if we want to apply a edge detection. So how can we do that in Python? So that we will see at the end of this class. So let's get started with the MCQs. So the first one is which of the
So
following,
sorry to disturb you.
yes.
Sir, actually, can you repeat what you said? There was a network issue. That's why I was not able to
Okay, okay.
listen
So
you.
what I told is in today's class, now after understanding the basic operations which happens in image, now we'll solve this MCQs. In between, we'll solve some numericals of these mathematical things, that how to do histogram equalization or how to do contrast stretching. So we'll see it numerically, and then after we'll try to see some Python codes, that how to do the edge detections using the Sobel filter or the Laplacian filter, which you have learned in class. So that is a plan for today's class, and let's get started. Yeah. Before that, any questions in the uh, video recordings of this week or previous class? Okay, so if there is no question, now we'll move towards the question answer. So the first question is which of the following statements describes the term pixel depth? So number of units, it's a number of units used to represent each pixel in RGB space. Used to represent each pixel in RGB space. Bytes used to represent each pixel in RGB space. and bits
Sir,
used to.
bits, number of bits used to represent each pixel.
Yes, so it's a number of bits. So the correct answer is option D. Okay. The next one is which of the following is the first and foremost step in image processing? Image acquisition, segmentation, enhancement, or restoration?
Sir, acquisition.
Yes. So before going to start anything, first you have to acquire image. Once if you do not have an image, you cannot start. Okay. The next one is filling the blank determines the quality of a digital image. The discrete gray levels, number of samples, discrete gray levels, and number of samples, and none of them mentioned.
Sir, C.
Yeah, so discrete gray levels, or you can also say it's a radiometric resolution, or how sensitive this image are, capturing the different intensity and number of samples, cells. Now, which of the following is the role played by the segmentation in image processing? Segmentation deals with the property in which images are subdivided successively into smaller regions. It's a
Sir,
partitioning.
A.
Hmm, okay. It's a okay. So why A?
Sir, as we divide our like image into smaller regions and then we apply some of the operations
But
to
segmentation, it
enhance
means
it.
like just it will segment anything from your image. So it will try to homogenize the similar part basically. So why not the option B? I mean, in this same case. So successively, it's not. The first option is not correct. Why? Because see, deals with the property in which image are subdivided. So we are not subdividing image. We are finding the pixels which are similar. Okay, we are not dividing it, but basically we are making a portion of like if pixel are similar, we are making a one cluster of it, and it will make a one particular object. So it might be small, big, anything, but it's not exactly that we are dividing the image into small chunks.
Yes, sir, got it, sir. Understand.
Okay, so the option
Yes,
B is correct here in this sense. Then C is like deals with extracting attributes that result in some quantitative information of interest. So attributes we can't because it's just image. So pixel values is there. So that thing we cannot do because we cannot get the attributes is like the height of the building or width of the building. So that directly we will not get from the segmentation. Then the thing is next is deals with the technique for reducing the storage required saving an image. So that is like just a compression, not the segmentation. Which of the following is the primary objective of sharpening of an image? So why do we sharpen our image? Decrease the brightness, increase the brightness, highlight the fine details, or blurring the image.
sir, highlight fine details.
So what are the application of this? So where do we need to sharpen our image? So
Sir, we can use it in some medical terms also, like we do some
yes,
diagnosis tests. So there
yes.
are some reports in which we have to find the actual like where is which part is malfunctioning.
Hmm.
So there we can use this filter.
Yes, and if we say in general about the, let's say, normal images, then if flood came and then there are buildings, so how many buildings got damaged because of the flood? So you can identify the details of width, height, or width and then width of the building or any other object which are there on the ground. So those things in terms of natural hazards. Next one is which of the following best describes the purpose of contrast stretching in digital image processing? To reduce image brightness, to redistribute pixel
So
intensity.
uh, redistribute pixel intensity to occupy full dynamic range of our histogram of
Yes.
our.
So basically, in our image, the values are from 0 to 50, or let's say from 50 to 100 only. But we have full range from 0 to 255. So we want to use the entire range so that we can discriminate between the different objects. So the thing is, let's say while clicking the image only, why can't we do that? So why do we have to apply this operation afterward, not before the taking the image? Can we do that before the taking image? See, the problem here is we are not able to use the fully dynamic range. So basically, when we design a sensor, we design a radiometric resolution, which we learned in the remote sensing, which is 2 to the
So
power
like
n.
before taking image, we can set our like there we have some options in our camera, but generally we do after taking photo.
Okay, so the answer here is like, see, the sensor which you have designed, that is for n number of object. Okay. Now, let's say you are taking just image of a leaf, or image of just one bottle, or let's say just image of this phone. So what will happen that whatever color of that phone is, let's say if it is green, then it will just give the higher values in green patch only. So you do not have any other colors. Okay, so basically because of that you do have full range. But the object which you are capturing, that is not having multiple colors. And because of that you already captured the photo. Now within that object also what is happening that you want to see. So anyway you are having excessive range which is available to you because your data or object is having very less color variation. So what you are doing is you are trying to show the more variation. Okay. So basically, when we design the sensors, we design for lots of things. But when we are doing it, we are doing it for one particular object or a segment of an area or part of an area. And because of that, it will not utilize the full range. And that's why we are doing this contrast stretching to use the full range. Next one is, suppose an input image has an intensity value concentrated between 80 to 150 on a 8-bit scale. So 8-bit means 2 to the power 8, so 0 to 255. Which of the following sentence is true for this image? So which of the following sentence?
So intensities between 80 and 150 are linearly mapped to 0 to 255.
Okay, the option B is correct. Just a minute, you think I understood. So which of the another one is also correct here, or any other option is right or wrong? So let's start
So
with
I
the.
had not sure for this C, but it may like intensity is greater than 150 are flipped to 255. Yes, sir, it is right.
True. Okay, so B and C both are true. So our correct answer is here D, not the B and C, because D is having B and C both are correct. So the meaning of the option number C is, if you have value greater than 150, then all of it will go to 255. Like, because it's already being shown that your image is just 150 only, so 150, it does not have any value more than 150. So 150 or more than it will assign it as a reassign it as a 255. Okay. The next question is, what happens if the minimum and maximum intensity values of an image are already 0 and 255 before the contrast stretching? So you want to do a contrast stretch, but the histogram which you already have that are having the value from 0 to 255. So in this case, what
Sir,
will
will
you
have no significant effect.
do? Yeah. And still, let's say if you want to do, can we do it or not?
So can you repeat the question?
So what I am telling is, let's say in your image, you already have the value 0 and 255. Okay, so basically what I am saying is, uh, so in the histogram, it's like this. Okay, and this value is 0, and this value is 255. But the value at 255 and 0 is not exactly 0. I mean, histogram, what it will give you, that how many number of pixels are having the intensity value of 0, how many pixels are having the intensity value of 255. So here if we see the histogram, then we can see that let's say few pixels, let's say x pixels are having the value 0 and y pixels are having the value 255. Okay, as per this question, minimum and maximum intensity value of an image are already having 0 and 255. So 0 value is also having, 255 is also having. Okay, and then if we are doing contrast stretching, then it is insignificant. So your answer is right. But what I am saying is that can we do the contrast stretching, like will it improve the image or not in this case when we have histogram like this? So basically, when we talk about contrast stretch, means what? We want to see something differentiate between two things. So here you can see for all the pixels, few values are common, like all have some kind of intensity. So I can put a line here, okay, and I can remove all the pixels value. Let's say if the let's say pixel is like, what I can do is I can just trim it, and then I can do the
Sir,
minimum. Yes.
are you talking about gain and bias in which we set our offset
Yes,
to
yes,
zero?
exactly, exactly. Okay, so now if I do this contrast staging using this limit and this limit, then because of this offset, it will improve the image. It will act as a similar kind of contrast stretching only. But yeah, compared to the if already have 0 and 255, the amount of significance is very less. But yeah, it will show the differentiation ultimately. Okay, so the option A is
Yes,
wrong
sir.
because the image will lose contrast. No, we can do the it will not lose the contrast. The image histogram will be equalized, so that is also not true. Pixel value will be halved, so that is also not true. So the option C is correct here, but yeah, uh, it's not no significant effect. It may have some effect also in this kind of cases, but not for every case. So now next question is like 8-bit grayscale image has intensity value ranging from 50 to 180. Now perform contrast stretching to map this range to 0 to 255 and find the new intensity of pixel with original value of 120. So basically in our image, which is the 8-bit grayscale image, we are having the value from 50 to 180. Now we are stretching to from 0 to 255 and we want to see now if the original value is 120, then what is the new value of that corresponding pixel. So how can we do this thing? Do you know anything like how to solve this?
Yes, sir. Like 120 minus minimum divided by maximum minus minimum. Just like 120 minus 50 and
Hmm.
180 minus 50.
Hmm. So I mean, do you know like how this formula got derived or?
So approximate zero point 0.5. coming. So just 1 minute, and we will multiply it also into by 255.
Hmm.
So, so like approximation is 127, approximate 27.
One.
So 127. Yes, sir. I applied this same formula 120 minus 50 and 180 minus 50. Like the number minus minimum value of digital number divided by maximum value of digital number minus minimum value of digital number multiply uh, bit like 255. If we have 8 bit, if we have 16 bit, then we will multiply by 16,000 something, that to the power 16.
So here we have 8 bits, so 255 will. But
Yes,
see,
sir.
this is like you this is mathematical procedure. You will get this value. But do you know how do we arrive to this equation? So if I tell
So
you
there
to
is a
derive,
derivation.
if I tell you to derive these equations, or let's say you do not, you forgot this equation during your exam. Okay, I hope this thing will not happen. But let's say you don't remember this equation, then what should we do here? Okay, so first of all, what we have to do is we just make a histogram like this, which is the range is 50 and 180, and the overall range is from 0 to 255. Is this clear? First of all,
Yes, sir.
and now what we want to do is we want to find a pixel value which is corresponding to 120. Okay, now first what we will see, we will find this range. So what is this range from 50 to 180? So what is this range? 180 minus 50. So my original image has ranged from 180 minus 50. So how much this will become? Let's say we'll keep it like this only. Now the range of new image, which is from 0 to 255. So that will become how much? 255 minus 0.
0.
Is that clear? First of all.
Yes, sir.
Okay. Now what is our range which we have to find is from 50 to 120. Okay. So we want to see how much this distance is being changed from 50 to 120. Okay, so that will become 120 minus 50. Okay, is this clear till this point?
Yes, sir.
Okay, now see the range which is 180 minus 50, that range is being converted into 255 minus 0. Okay, so this will go here. Okay, so original range is from 180 minus 50. That range will being converted into 255 minus 0. So if the original range of this 50 to 120, if it is x, then that range will converted into what? It's just normal interpolation which we are doing. Okay, so what about this one? So what will happen? 120 minus 50 multiply by 255 minus 0 divided by 150 minus 80. So it will give you the same formula. Got my point?
Yes, sir.
Okay, now see this formula will give me the what is the new value corresponding to this initial point where we are measuring this value, this new range. So this new range is from 0 to 255. If the new range is given to 10 to 255, then this distance is from 10. So in that case, if it is from 10, then we have to add the distance from 10. Here it is from 0 only. So if we put 0 also here as minimum, it will become 0 only. But if it is 10, then we will put 10 here. So it will make the offset. So this is the gain, and then this one will be the offset. So this is just very simple mathematics. So basically, when we have this kind of similarity of triangles, and let's say this value is 5, and then this is 0, then we will see at let's say 5 meter. At 5 meter, if it is 5, then what is the value at 3 meter? That we have to find. Okay. So that we have to find. So let's say basically, if we have range from 180 to. So basically, did you get my point? Like how we arrived to this formula?
Yes, sir.
Okay. Okay. So now so that is the simple thing, like this linear interpolation where we do. Now, the next question is, which of the following is true about smoothing or low pass filter?
So to reduce noise in small details.
Okay, so the first option, it will reduce the noise and small details. Okay, so next one is, median filtering is particularly effective at removing which kind of noise? So median filtering. So there
So
are like,
Gaussian noise.
no. So median is a low pass filter. So basically, median is useful for to remove salt and paper noise. So I think, I don't know you guys know or not. Let me show you. So basically, when you apply medium filters, it's first of all low pass filter. So there are three kind of low pass filters are there: averaging filter, Gaussian filter, and median or mode filter, which are like kind of non-linear. So basically, when you apply this median filter, what it will give you, the median value of a pixel it will give you. So how it is useful? It is very effective for removing this salt and paper noise, which is like this random occurrence of black and white pixel. So basically, when you apply this filter, the extreme value will move out. Like if it is value is 255 or if value is 0. So if just dark or white pixels are coming in your image, it will get removed, and instead of it will fill the median value of the nearby pixels. And because of that, so here in this image, if your image is like this, if you apply the average filter, then it will look like this, because we are doing averaging. So if pixel is white, that region will become white only. But if we apply the median filtering, then it will become like this. Similarly, this is another example when you have this salt and paper noise. Salt and paper means like black and white pixels coming in between. Then it will become like this. So okay, similarly, this is another. So this is useful for denoising application. So if you want to remove noise from your image, you use this median filters. And similarly, there is a mode filter also, which is also useful for removing noise. Any doubt?
No, sir.
Okay. The next one is, which of the following is a property of high pass filter mask? All positive coefficients that sum to 1, coefficients that sum to 0, symmetric Gaussian distribution.
So coefficients that sum to 1,
Coefficient that.
sum to 1.
Okay, let's go back and check the kinds of high pass filter. So this is the kind of high pass filter. So the element of mask contains both positive and negative weights, and mask element sum should be 0. So basically, if you see the Laplacian filter or some other filter, so this is kind of high pass filter where you, if you like sum all the elements in the high pass filter, it will become 0. The sum of it will become 0. So these are different high pass filters. Okay. So basically, the answer is coefficients that sums to 0. The next question is the Gaussian filter is preferred over a simple mean filter because of it enhances the edges better, it gives the higher weight to pixels farther from the center, it preserves the image structure while smoothing, or it works only on a binary image.
So preserve image while smoothing.
Yes, so that is true. So can you explain it mathematically? Like what happens in Gaussian filter? So that's why it preserves the structure and also does the smoothing. And basically, if you want to compare the mean filter and Gaussian filter, your answer is correct. But like, can you express it mathematically?
So I think it copies the pixel values from its side pixels.
Which
So
one?
that's why it can maintain. So goes in Gaussian filter.
No. So first of all, what happens in the mean filter?
So it takes the average of surrounding pixels.
Yes, that's true. Chal. So mean filters do the averaging. Now, what does Gaussian filters do? How it calculates the value? So Gaussian filter use this Gaussian distribution curve, which is a bell-shaped curve. Okay, so in that it's similarly like this. Okay, so it uses this Gaussian distribution where these functions are normal functions, and basically you can see here, if you see the weights of Gaussian filter, then this Gaussian, wherever this Gaussian values are high, there the weight is very high, see 60. And as you go away from this weight, in this side it is 88, then in the diagonal it's 4, and then as you go further away from the center, the weights are decreasing. Okay, so because of this, what will happen that if you have sudden change in your image, okay, so basically it applies this kind of weight that it will multiply higher value to the center and lesser value to the cider parts. Now let's say if you have some image, okay, where you are having this kind of boundaries. Okay, so boundary what will happen that pixels values are changing abruptly. Okay, so here if you apply mean filter, it will just mean the value. Okay, it will just it will take the mean of all the pixels in the nearby region. And because of that, you will get the smoothen image like this. But in case of Gaussian, what will happen? Like if you will take Gaussian is small, then it will preserve the boundary also or edges also. Because when we apply here, when our kernel will go over this particular point, wherever the values are high, it will give more weightage, and corresponding to these other part or the nearby pixel, it will give less weight. So we are able to extract the edges. Okay, so basically it blurs the edges, but like not too much. Okay, so it if noise is there or some kind of edges is there, it smoothens it, but not as good as like this mean filter are doing. So basically, because of that, it preserves the features and ultimately it removes the noise also. So if some noise are coming, it will remove that, but it will try to preserve the edges. So that is the advantage of Gaussian. Whereas in mean filter, it will just smoothen down the entire image, even if it is a edge or no edge or any sudden pixel value. Do you get my point?
Yes, sir, but can I ask a question? So, like in smoothing filters, besides of they are reducing the noise. So,
Mhm.
beside of this advantage, what is the other advantage of smoothing filters? Because like these are giving our blurry images.
Yes.
But
So,
if we talk about sharpening filter, so they are highlighting the details and highlighting the fine details. But this is okay. But in smoothing filters, they are doing images blur. So what is the advantage of these filters?
okay. So first of all, I will show you in the what kind of low pass filters are there. Okay. So low pass filter is first of mean, median, and mode filters, and then there is a Gaussian filter also. So you can see this image, original image and mean image. So as you told, like this, it is blurring the image. So we do not have any sense of it because see, here also the original image is having more details. But as we are improving the kernel size and if we are making it to low pass filter, we are not able to do anything. Okay, similarly here. So first of all, median filters are there, which will remove this salt paper noise. Okay. The first application of low pass filter is to removal of salt and paper noise. And this noise is coming in satellite imageries. So in satellite imageries, if one sensor or one particular part where it is sensing the signals, if it is not that correct, it will provide the salt and pepper effect. And to remove that in satellite image, we use this median filter. Apart from that, when we work with the SAR data, if you have heard of, so if you want to do any flood applications, we are working with SAR data because it's independent of weather. And SAR works in such a way that if the if water is there and nearby to water, if land area is there, so backscattering will be high from the land area, whereas backscattering from the water area will be very less. So it will create a noise that at one location scattering is very high and one location it is very less. So before doing the any application to detect water, we apply this smoothing filter to our entire image so that it can remove the noise and collect the proper water pixel rather than capturing the noise. So that is another application. Third application is so this is like mode filter, mean filter. So if one is salt paper noise, second one is the in our images we use this, and the third one is let's say if you want to train a machine learning model that you want to give multiple your features and it should train you that whether it's a dog or cat or bicycle or car or which kind of car or something. Then in this case, both will be helpful. The sharp high pass filter will give you the idea about the height, width, and all those things. And this low pass filter will give you the idea about the distribution of that pixel, that how scale, like how big the scale of that image is, how is making a neighbors, how nearby pixels are connecting with the another pixels. Because in high pass filter, we'll just get the edges only, not within the edges what is happening. So if I having car, I want to detect a car. So if I apply the high pass filter, it will detect the shape of car, but which car it is, that it's a blue car or black car or green car. If I want to do those kind of thing, probably this low pass filter will help you in that case. And because of lights, so many colors are coinciding with each other. So this will helpful in removing the noise and making the color homogeneous. Getting my point?
Yes, sir.
So these are the three applications which I know. I mean, there might be another applications also. Uh, uh, Another case is I don't know. So if you have worked with hydrological data, then there we use this low pass filter which is on time series data. So there we extract the contribution coming from the groundwater. So groundwater has very steadily values, and the values are very less compared to the water which is flowing in the river. So while applying this after applying this low pass filter, we will able to extract the water which is coming from the groundwater or the which is coming from the subsurface. So that is another application which we use in hydrology, and that also for time series data, not for the image data. Okay. Yeah. So I just
Yes, sir.
those applications. Then the next one is which filter is based on the computing first order derivative of the image. So Laplacian, Sobel, Gaussian, and median. So first of all, first order derivatives are high pass filter or low pass filter.
Sir, high pass filter.
Yes, high pass filter. So these two are low pass, Gaussian and median. So this option C and D are cancelled. Now from A and B, select which one is true.
Sir, Laplacian.
So Laplacian is second order derivative. Sobel is the first order derivative. Okay.
Yes, sir.
So
Like, don't know about the details of
yes,
these
yes. But
filters.
yeah,
Like,
that,
we
that is a
just
very basic thing you should know, because see, when you apply a threshold, if the formula is del f by del x or del f by del y, it is known as a Sobel filter. And if you are just taking one differentiation only, so that's why it is initially it will help to detect. So if you apply this del f by del x, then you are doing the differentiation with x axis. So what will happen in that case? It will try to get the details which is in y direction. And when you apply this differentiation with y, it will try to get the details which is in x direction. Okay. So that is the first direction. And see, this is extracts horizontal edges, and this extracts the vertical edges. So basically, this Sobel filter helpful in the extracting the edge. Whereas if you go to the second one, which is Laplacian filter, where you specify the derivatives by del square f by del x square plus del square y by del y square. Though in that case, what will happen that it will help you to detect the directions of those lines which you edges which you extracted. So Laplacian localizes edges better using the zero crossing, whereas higher order derivatives are typically more sensitive to noise. If noise is there, then they will not able to perform well. So Laplacian is less computational expensively. So if you want to use Laplacian, it's like you can extract the edges quickly. Whereas if you want to do first order derivation, it will take time computationally. Then Laplacian can provide age magnitude information but no information about age direction. So what it is showing is you are taking del square by del x square. So you are multiplying it. So it will lose the information whether it is in x direction or y direction. It will just tell you that at this particular point the edge is sharper or less sharper. Basically the edge is there. But if you use Sobel, it will help you to detect both the direction in X also, like sorry, basically your edge in X direction as well as edge in Y direction. So whereas Laplace will just tell the edge is there. It will not specify the direction of edge, whether it's in a X or Y. So got my point? I mean, these things you should keep in mind. Okay.
so means Laplacian has only magnitude while Sobel has magnitude as well as direction.
Yes. So Sobel is gives direction either in X, in Y, or in both direction. Whereas as you
Just
go to
like
higher
vector
order
quantity.
derivatives, yes,
So like just like Sobel is vector quantity or Laplacian we can say scalar.
yes, kind of you can say it, because in Laplacian you will just get the value whether its edge is there or not. Whereas in Sobel you will get whether the edge is in X direction or Y direction. Okay, so the answer here is the Sobel filter. Now, given the following 3 by 3 pixel neighborhood of a mean filter, apply a 3 by 3 averaging filter, all weights 1 by 9. What is the new center pixel value? So calculate it. What might be the answer? So how will you do it? 1 by 9
I
into
some that
sum.
firstly I will add these all values and then divide by 9.
So basically you will do the sum of all the and then divide it by 1 by 9. So the answer will come around 98. Now the next one is apply a 3 by 3 median filter to the following neighbor. What will be the new value of new center pixel? So how will you do this one?
Firstly I will arrange them in decreasing order and then
Yes, you
the
will arrange the
median
values
value of
in
this series
ascending orders.
and then the median value of this series will be the new center pixel
Yes.
value.
So here if we arrange it then 23, 23, 23, 25, 34, 45, 58 and 76. So basically we'll take the fifth value which is 25th. So our answer will be 25th. Now if I apply mode filter here then what is the answer? So if I apply mode filter here then what will be the answer?
So 23.
23, yes. The next one is a Laplacian filter has a following mask. If the central pixel is 100 and neighborhood pixels are 50, what will be the new central value? So you create a first matrix where center value is 100 and the rest of it is 50 and then apply this filter. So in center it will become 100 into 4, whereas in the sides,
400.
yeah, in sides it will become minus 50, minus 50, minus 50 and minus 50. So minus 200 it will become.
Yes.
So 400 minus 200 which will become 200. Okay.
Yes, sir.
Yeah. So if any point of time if you are not getting to like know like what is happening in the numericals, let me know. I will write it and solve it. If you are getting it, then we don't do it. Which of the following statements about Laplacian and Sobel filters is correct? Laplacian provides edge direction while Sobel does not. Sobel is computationally cheaper than Laplacian. Laplacian localizes edges using zero crossing, and both filters are nonlinear.
So Laplacian localizes as is using zero crossings.
Yes, right. In practice, why is a Gaussian filter often applied before a high-pass filter like Sobel?
So to reduce noise and prevent false edge detection.
Hmm. The next one is which of the following operations is done on the pixels in sharpening the image? Differentiation, median, integration, and average.
The median and average are smoothing filters.
Median and average are?
Smooth. So just
See, think about the word. What we have to do? Sharpen. Sharpening we do
yes, sir.
using which filter?
So differentiation.
Exactly. Why? Because see, we have to do sharpening. Okay, not the smoothing. Smoothing
Yes,
we do using median and average filter. So it will be
yes, sir.
popped
That's
out.
why.
Okay, and then remaining is Sobel filter and this Laplacian filter, which are based on the differentiation.
Yes.
Which one is the principal objective of sharpening to highlight the transitions?
The composure.
How composure? I mean, I don't know. How? I mean, can you
So
rephrase it?
not sure. Just so like brightness is increasing intensity
So
values of all.
basically, the intensity, if it is too high or if intensity is changing, then it will be like, see, brightness it looks, see what we told, like brightness is like for all pixels. In starting of the class, we
Yes, sir.
told. So when you are considering
Yes, sir.
entire image bright, like light, how much is falling on entire image, then we consider brightness. But here, what we want to do, we want to sharpen the image or we want to get the edges and all. So when we have edges and all, then it will be like intensity. At one edges, intensity is coming very high, and then another edge is because edge is there, so shadow will form. So it will be black in color, and because of that, intensity will suddenly drop. So all is because of the intensity. Pixel density will be same only. Composure, there is no, I mean, can be useful there. Which side of the grayscale is the component of histogram concentrated in a dark image? So dark image have histogram in which side? Skewed towards what?
So dark low, sir.
Hmm. So the next one is an image histogram shows a strong peak at high intensity and which is on right hand side. With pixel, very few pixel at low intensities. What does this most likely indicate about the image? So almost all the pixels are on the right hand side of the histogram. So what does that mean? The image has high contrast with equal distribution of dark and bright pixels. The image is
Sir,
underexposed.
overexposed with most pixels being bright.
Yes, true. The next one is if the histogram of a grayscale image is narrowly concentrated around the mid intensity values, what property does the image most likely have? Basically, the histogram, what the question is talking about, that the histogram which you have, it's something like this.
Sir, high contrast with sharp edges.
Mhm. How? See, you have to understand the words properly. Okay, when we say contrast, what does that mean? That there are black pixels, there are white pixels, and you are creating a
Yes,
contrast between that. But here, what is happening? That you are just having the value in just one portion. You do not have dark pixel, you do not have bright pixel. So, if you do not have dark and bright, how will you create the contrast? Okay, if I'm talking about
by
contrast,
contrast stretching.
then in that case, my image should be like this histogram. Then this portion will represent the darker part, this will represent the brighter part. But here it is already given that my image is like this, that all the images are narrowly means this is very narrowly means like this.
Sir, bimodal distribution with distinct dark and bright region.
How it is bimodal? See, in question read, if the histogram of a grayscale image is narrowly concentrated, narrowly means the distance between this peak is very less, and it is
Yes,
concentrated
sir.
means it's high towards the mid intensity. So if it is 0 to 255, then in between, let's say around 155 or 150, it is having highest values, and in that region only, nowhere else. So this we will just opt it out because this is not right option, because if there is no white and no black and everything is concentrated at mid section, then there will be no high contrast. So that option is wrong. Now low contrast and looks flat or washed out. Bimodal distribution with distinct dark and bright. So bimodal is also not true because it's already told that it's just having one peak which is in middle, and in bimodal there
Sir,
should be two peaks.
sir, I was saying like bimodal distribution is maybe the solution for this problem. Like if you want to create, if you want to solve this or you want to correct it, then we can create bimodal distribution in this histogram.
But see here what's already given, that histogram is just one model only, like
Yes,
one
sir.
peak only, no other peaks. So option C is also wrong. Overexposed image is like this peak is on this side. If it is this same thing is on this side, then it might be referred as an overexposed image. But it is in center, so we cannot say it's overexposed image also. So technically the correct answer here is this one. But why? Because there is no pixel in black, no pixel in white, so contrast is very less. First point, and then everything is in middle range. Then it will look like as a same color. Flat means almost you will see same color, gray color, and it will look like that you are seeing an image which is washed out or which is very light. So basically, if I open PowerPoint and let's say if this image is there, I will go to pictures and corrections. So washed out means it's like this, or else we will go to transparency like this. You can see when we apply the transparency like that, during that time, whatever the image will become, our image will look like that. So everything is washed out. And here also in effect, if you see, there might be some effect of washed out. This is blur, glow. So basically, it will become the washed out image. Got my point? Or any confusion is
Yes,
there still
sir.
in this question?
No, sir, got it, sir. So
Next,
sometimes concepts are clear, but like I don't understand the language and the what question want to ask.
okay,
Language of the question.
so focus like just rather than asking why that option is right, question that why it might be wrong. So delete the option rather than selecting the correct one. If it is directly
Yes.
detectable, then it's fine. Otherwise, delete the not clicking to your mind, then delete the option which is not right to you. Which operations would most effectively transform a low contrast image, histogram concentrated around the center, into one with better visual quality by spreading the pixel intensity? So this is we are talking about, like, now if we have the histogram like this, how we can make it clear image? Which technique will help us?
So histogram equalization.
Yes. So have you done this histogram equalization?
Yes, sir.
Okay, like
So like
mathematically in book
we did
or
no, sir. Like we did in this way. Like we got an image and we opened the software and there were options to apply histogram equalization, low pass filter, high pass filter, sober
okay,
length.
but
Then
see
we
if you
click and get the output and just see the results and just see the difference before or after the image. Just
okay,
like this, not
so
in
when
much
you
detail.
okay, so when you apply histogram equalization, how your image happens, like looks before and after? Any idea? I mean, okay, if
So
not, then we will see it today. Don't worry. Consider the grayscale image whose histogram shows two distinct peaks. Now, two distinct peaks means bimodal distribution. One near intensity 50 and another near intensity 200. Which statement is most accurate? First, make a figure that you are seeing two peaks like this. One peak is around 50 and one peak around 200.
contains both dark bright regions and indicating a bimodal distribution.
Yes, that's right. When performing the histogram equalization on an image, which of the following statement is true? So the first one is the mean intensity value of the image always shifts to 128. So here we don't know what is 128, so I think we'll not go to the option 1. Second is the cumulative distribution function is being used to remap the pixel values. Third one is the output histogram is always perfectly flat. So if it is flat, then there is no need to do the equalization. Like as
So
the
this
name suggests,
cumulative distribution function.
yes, so option B is correct. But don't go with the words like histogram equalization. It doesn't mean that you are making the histogram flat. Okay, some people who do not
Yes,
have any idea, if they go to exam and they will write this only because equalization means that only, that making it flat. So it's not like that. Okay.
yes.
Now let's say we will have one image in which histogram is given in this box. That pixel like pixels having value 0 are 10, pixel having values 1 are 8, 2 are 9, 3 are 2, 4 are 14, 5 are 1, 6 are 5 and 7 are 2. So basically 51 pixels are there in the image, and then this is the distribution of it. Now if we apply this histogram equalization, what will happen to the pixel values? Original pixel value 0, 1, 2, 3, 4, 0 to 7, which is 6 bit image, 3 bit, sorry. Okay. Now how these values will change? If the current value is 4, then how this will change to new values when we apply the histogram equalization? How this 4 will become? It will become same as it is. Will it become less than 4 or will it become greater than 4? So that we want to see. Understood the question?
Yes, sir. So like number of we will have to change number of pixel histogram value.
Yes, so basically, if you take any image, okay, you will get the histogram, or basically, if you do not have histogram, you will get some kind of matrix like this. Okay, so there we have, let's say, written values like this: 1, 0, 0, 8, then this might be 7, this might be 3. So this values, different values are there, and their image, our image is 6-bit image, or 3 bit, sorry, 3 bit, so 2 to the power 3, so 0 to 7, so value can go to 0 to 7 only, anywhere in this 4 by 4 cross matrix or 4 by 5 cross matrix, values can range from 0 to 7. Now I will calculate how many times 1 are being repeated. So I will count that 0 is 10 times in this matrix, 1 is 8 times in this matrix, 2 is only appearing for 9 times, 3 is appearing for 2 times, 4 is appearing for 14 times, 5 is appearing for 1 time, 6 is appearing for 5 times, and 7 is appearing for 2 times. So now you can see some values are very less, like 5 is appearing just 1 time, 3 is appearing just 2 times, and 7 is appearing for 2 times. Whereas most of the values are appearing for 0 and 4. So why don't we stretch it? We use this value and we make our histogram stretch, but not using contrast stretching, because here it is not on end, like it's in center. So this lesser pixels are in center. So either we can do the piecewise stretching, or else we can go for histogram equalization. So to do that, like, now the question got clear or not?
Yes, sir.
Okay, so to do histogram equalization, first we'll find out the running sum. So 10, 10 plus 8, 18, 18 plus 9, 27, 2, 27 plus 2, 29, 43, 44, 49, and 50. Then we will normalize the value of all the pixels. So 10 divided by total number of pixels. So total number of pixels are 51. So 10 by 51, 18 by 51, 27 by 51, similar to that 51 by 51. So now this will become, like, if it is value is 0, then the new values which we are assigning, that will become 1. If the old value is 1, that will be redirected to the 2. If the old value is 2, that will redirect to 4. 3 will redirect to 4. So here we are not having 0, 3, 5, like that. So hello, Janmejai, and we also have,
Hello, sir.
yeah, hi. How are you?
Good, good.
So can you just introduce yourself in this brief?
Actually, my name is Janmajit Tiwari. I'm a working professional.
Okay,
I'm working in GI sector.
okay. And which kind of job you do or work you do?
Uh, as a GIS expert.
Okay, nice. So are you doing this course or just applying for exams or?
Uh, no, I did not apply for the exams.
Okay,
I'm just studying the course.
okay, fine. So what we're discussing right now is we are discussing different types of digital image processing, what kind of filters
Okay.
are there, and currently we are seeing the histogram equalization. So how we can do it mathematically, because in softwares you do just directly histogram equalization and it will show you the results. But what do it do in backhand? So that we are discussing now.
Okay, sir.
So basically I will repeat again for you. So have you done this histogram equalization before or?
Long back, I have done actually, not recently.
Okay, so you know, like, concept it is used for to stretching the
Yes.
histogram and all.
Actually, I have done masters in remote sensing in GIS.
Okay, that's great.
Yeah.
So basically, I will repeat again. So we have a image which we represent it as a matrix, and then it is having 3-bit image. So values can range from 0 to 2 to the power 3, so 0 to 7. And then the values are from 0 to 7, and this is showing the frequency of the pixel. So pixels having the value 0 are 10 number of pixels are there which are having 0 value, 8 numbers of pixels are there which are having value 1. So to do the histogram normalization, what is our task is, we want to see what is the new value of original value 4, or original value 4 pixel will convert it into which value. So first we will do the running sum, 10 plus 10 plus 8, then 10 plus 8 plus 9, 10 plus 8 plus 9 plus 2. So we do the running sum, and then we will normalize the value using the total number of pixels. And based on that, we will find it, and then we'll multiply it by 7. So 7 means this is your entire bits what you have. So you will get this value. So original value 0 will transform into 1, original value 1 will transform into 2, 2 will be transformed into 4. Similarly, 4 will transform into 6. So like this histogram equalization works. So you can see now here it has compiled the value of 2 and 3 into just one class only. 4, it has compiled the value of 4 and 5 into 6. Now also you can see the ranges are from 1 to 7. So you can apply the contrast stretching also. You can make it from, instead of 1 to 7, you can make it to 0 to 7. So that is histogram equalization, and then after you are doing contrast stretching. So basically it will help like in this way. So you do have one image, and then histogram of this image is like this. Now cumulative histogram. So cumulative histogram, that what we have done over here in this particular line, the accumulation running sum which we did. So that will make it to 1. So here after dividing it by total number of pixels, if you go here it will become 1, and over here it will become around near to 0. So it will be like this cumulative histogram. And once you do the normalization, it will look like this with a particular slope. So earlier the histogram is like this, and once you do the histogram equalization, the slope will become like this. So that is like mathematically you are doing something like this in histogram equalization. So basically what we have done is this histogram we stretched and we make it into this way, so assigning the new values. So now earlier it is ranging till 250 something, and now it is going beyond that also. And you can see the feature also, it is now like this total white pixels, because those are in this particular region. So those ghosts distributed very well, and that's why you can see here in this all the white, here it's looking similarly all white, but here you see you can see the shades also, white and black depending on the shadow. Okay, now the next question is, which of the following is the application of histogram equalization?
So contrast resistment and image enhancement.
So mostly we'll go with image enhancement, because we do not do contrast enhancement every time. Okay, we do, but not every time. So specifically it refers to as image enhancement. So contrast adjustment will also come inside that one. The next question is, which filter is known as averaging filter?
The low pass filters.
What is or are the resultant image of a smoothing filter? When you apply a smoothing filter to your image, what will happen? Image with reduced shape transition in gray level, image with high
Yes,
sharp
sir.
transitions, none of the above or all of the above?
The reduced sharp transitions in gain levels.
Next one is, which or is or are the features of high pass filtered image?
So emphasize transitional gray level details.
What? Which
Sir,
one?
emphasize transitional for C.
You read the other options also. Why not the A, B, and D? See, whenever it's written that all of the above or none of the above is written, then you should read the other options carefully.
Sir, A is okay, like overall sharpness, but in D have less the level variation in smooth areas.
So that is also true, na, that if the less like have less gray level variation in smooth areas. So area is already smooth. That's why it will not pass it. It will just pass the things which are having contrast or like in sudden intensity change.
Yes, sir. Yes, sir.
Okay, so
Thanks
that
for the
option is
word.
also true. So all of the above. And even if like A and C are correct, then you should go with B most probably if it is a single correct. Next one is the incorrect statement about a pixel is a pixel is a digital sample of an image. Each pixel represents one single DN value. Pixel is an element of analog image, and a pixel is a sample of a continuous function. Which one of the following is incorrect?
C.
Which one?
Sir, C. Element of the unknown image.
B.
Sir, C.
C. Because it's a element of digital image, not the analog image.
Yes.
How does increasing the gray levels affect the image quality? It allows the finer level of details to be easily identifiable in the image. It decreases the clarity of details. It reduces the
Sir,
number of pixels in the image, or it increases the spatial resolution of image.
sir, A.
Yes, it's true. Radiometric distortions is not affected by. So which of the following factor is will not create
Sir,
radiometric?
relief displacement.
Yes. So which kind of distortions it will create in image relief displacement? If not radiometric, then which kind of problem it will create? So relief is like angle and distortion in heights. So it will create mostly in geometric resolution, create some problem, not fully, but something in geometric. Unless if like we have that thing that image, if it is permissible angle is 3 degree or less than that, we consider that as a vertical photo or vertical image. But if that angle is there and building is too big, then it will create relief displacement, which ultimately lead toward the distortion of image. So it's a geometric distortion. Dropped line in a satellite image are normally corrected by replacing the line with which one? Above and below. So option C. A second order polynomial transformation in georeferencing of remote sensing images requires a minimum number of it's 6. For 3 order it's 12 and 1 order it's a 3. The geometric distortion in satellite image is not affected by yes, so DN value will not have any relation with the geometric distortion. What is the image resampling? Which one? Okay, so the correct answer here is option B, C, and D. All three are correct answer. Because it's a technique of generating an image of a new system coordinate. So that is true. Like when we do georeferencing, we need to do image resampling. The second thing, when we do resampling, the value of pixel will become an important role, the intensity value. Because according to that only we will apply the nearest neighbor or bilinear or cubic type of methods to do the resampling. And the third one is it is the technique used to homogenize the spatial attributes. So that is also true. Your voice is not clear.
So, like, am I audible now?
Yes, yes, you are audible.
Sir, how we can get to know, we can select here only one or more options.
So like basically in NPTEL you will get checkbox either round or square. So if it is round, then just one option is correct. If it is square, then multiple options are correct.
Okay.
Okay, like you have in your assignments. Assignment also is in
Yes.
same way similarly.
Yes.
Which resampling methods are used only for continuous data?
Only for continuous bilinear or cubic.
Yes. What is the purpose of using piecewise linear contrast enhancement?
Sir, change the dynamic range of gray levels in selected part of the image. Option C.
True. The next one is the graphical representation of an image that provides the frequency of occurrence for each intensity level in the image is known as a
Histogram.
yes. The 5 cross 5 window of pixel values. If the most frequent value is 37, which is replaced by the central pixel, then this filter is used, whichever we used here is called as. So replacing the central pixel value with the most repeated
Sir,
or
mode
most,
filter.
yes. So which one is the incorrect pair about the filters? Incorrect, not correct, incorrect.
Sir, B or C. B and C
Huh.
are incorrect, sir.
Which of the following is a low pass filter?
Sir, just
Yes,
1 minute.
yes,
Sir, C.
yes. C is low pass filter. Now the next question is which of the following is a Sobel filter?
Sir,
Yes.
Sobel filter which has uh, direction as well as magnitude.
Yes.
Sir,
So
option D.
option B and C are correct. Those two are Sobel filters. Here just it's like it's just one is for x direction, one is for y direction. That's why you can see the transpose of matrix. So I
Sir,
mean for yeah, any question?
So can you explain the options of this question? Like,
Like the first two are A and D are Laplacian filters, and B and C are Sobel filters. And this is the one is a transpose of another. So when it is in just one line, like -1, -2, -1, and then in another one, it's a column is -1, -2, -1. So it's a transpose of each other, which means that one is representing derivative in x direction, one is representing the derivative in y direction. So that's why option
yes, sir.
B and C both are correct. And like before going to exam, NPTEL exam also, if you are appearing for GATE also, please note down the simple, like how does this filter will look like. Basically the popular filters, which are like Sobel filter or this Laplacian filter or mean, median, mode filter. So go through Pret filter. So all those filters you should know like how the kernel will look like in those pixels. Gaussian filter. Okay, so write it
Yes, sir.
down somewhere in your copy. And once you have exam, you just go through it.
Thank you, sir.
Okay, so basic identification is if high pass filter is there, the summation will happen 0. Like, okay, so that thing keep in mind. Similarly, some kind of technique will be there for other. In a low pass filter, every value will be similar and positive coefficients will be there mostly. Next one is why is the atmospheric correction necessary in satellite remote sensing data?
Sir, option B, accounting for scattering and absorption.
Yes. Which of the following is an example of radiometric correction? Correction for haze due to Rayleigh scattering, calibration of DN values into radiance or reflectance using sensor calibration parameters, removing the relief displacement using DEM, or registering images from different acquisition times.
Sir, option B.
Yes. If a Landsat image shows a positional shift of several pixels when overlaid on a reference map, which type of correction is required in the image?
Sir, geometric correction.
Yes. Choose the incorrect statement about image segmentation in digital image processing. Segmentation
Sir, option
divides
D.
option number.
D, sir, partitioning of an image into multiple sets of similar pixels.
It's an incorrect option, not the correct option.
Okay, okay. So just 1 second. Sorry.
Read it properly. This is a question from GATE examination.
Yes, sir, I'm very sorry. Sir, option A and B. A
And
is all
right.
for sure wrong.
See, you have to select the incorrect option. Okay. So earlier also we discussed when we do segmentation, it makes the bunch of similar like polygon or something like it will just identify the similar pixels. So basically
Yes,
what
sir.
does it
That's
do?
why.
Segmentation divides the image into different regions. So that is true. Depending on the similarity of the pixels, it will divide into different regions. That is true. Segmentation is option B. Image segmentation does not help in image classification. So that is not true because see, if in our image, if all the water bodies are there of, then it will have same values and then it will make a segment of it. If houses are there, it will make in one segment. If water bodies or vegetations are there, it will make into one segment. So if we use that layer for image classification, it will improve the accuracy of image classification because it will get to know that something similar is there. So when to classify the image, you should use that particular thing. So ultimately the segmentation will help in segment classification. Okay, so that's why option B is incorrect. Now also look into the other options. Segmentation helps to identify object or boundaries. So that is also true, because if all the pixels are water pixels, then it will create a boundary around those pixels, or it will show a high density area or very large area with water. Similarly, having a house or having a football ground. So it will
Yes.
help. And the last one is segmentation is a process of partitioning image into multiple sets of similar pixels. Here, multiple sets of similar pixels. That is true. But when we looked into this question before, then it was like we are dividing the image into subsequently, and that also in reducing the part of image. So that is wrong, because it's not subsequent and doing it like smaller and smaller. It's like if the pixels are same, it will create one class. So basically creating multiple sets of which are having similar pixel values. So option D is also correct. Got?
Yes, sir.
Yeah, so the next one is the sum of all the values of a normalized histogram is equal to. So normalized histogram will look like this when you do the image uh, histogram equalization. So the value will become 1. Okay,
Yes.
so the answer is 1. Okay, so let's write it clearly. Okay, so any doubt till in this digital image processing?
No, sir.
Okay, I highly recommend go through these chapters again. I mean, your concepts are clear, but go through the questions one more time. Solve the assignment in NPTEL, assignment number 9. And now just we have 10 minutes, so I will just give you a brief of course, how this course works actually. Mm, So basically, I have few images. So I will show you the images first of all. So I have this 3 images. One image is like this. So what is the problem with this image?
So, like, it needs to, like, we have to increase brightness.
Yeah, so it's very dark. So contrast is not there basically.
Yes, sir.
Okay, and it's like generally this kind of image we will capture during the night time or evening time or morning time. Similarly, there is another. So the previous image I captured during evening time, and this image I have captured during morning time. So another question: this red color in the sky is because of which kind of scattering?
Sir, relay scattering.
Yes, that's true. So now the thing is, in this image also the different things are there, but the contrast is not good because one portion is dark, one portion is light. So it's a bimodal distribution, and it will not work. Like if you just want to see, let's check it out. Uh, let's check it out the distribution of those two images first of all. How it look like. So you see here, like histogram is like this, very balanced, and it's like on one side and then another side. So one particular portion towards dark side and one particular portion toward bright side. So histogram is stretched, like showing bimodal distribution. Similarly, if I take the another image, here also see this is the one part and then this is the another part. Okay, so this is the problem with this image. Now, what I want to do is I want to do histogram equalization here. Okay, so basically when you do histogram equalization, what will happen? Image not found. So this code I have written in Google Colab, and like this I have not written. I have used taken the help of ChatGPT and Gemini to write this, but it's like based on what we discussed today. So basically, when you do histogram equalization, it's like similar thing. So this is the original image which you have, in which contrast is very less, and the histogram of this image is like this. So which is showing the two bimodal distribution. Now, if you plot this cumulative histogram, then it will look like this. So what we did is 10 by total number of pixels, 51 by total number of pixels, like that. So this is representing that. And now when we are doing histogram equalization, we want to make it straight like this. Okay, so we will make it like this by normalizing it and then reassigning the values. So this histogram will become into this one. And once we do it, then you can see now you can see a lot more detail. You can see this roadway properly, then this like kind of umbrella kind of structure, you can see it properly. Here in this land also you can see the that vegetation is not there, but here some vegetation is there. Clouds also you can see it properly. So this is, you can see the side by side comparison of before and after image. And if you want to understand the code for this, it's like similar what we did. So it will start with this main module. We'll give the image. We'll just check it whether the image is there or not. If it is not there, we will flag the error. Now it will go to this particular code for normalization, calculate cumulative histogram, and plot image and histogram. So basically, this is I am showing the image, and to do the histogram equalization, that's like there is a function known as a equalized image. So basically that variable which you got. So here you can write just one tool to do the histogram equalization, that CV2. This CV2 is a library, open CV, in which lots of functions are there for digital image processing. So from that I'm doing this histogram equalization. I will putting my image, it will do the histogram equalization, and then this is for visualization. So the rest of the code is for visualization. So I want to show everything. So for that, and then side by side comparison. Then similarly, if I use another image, and now my task is I want to increase the contrast here. Okay, but the problem is, see, the one which we discussed in the MCQ, that in the given image the pixels are already from 0 to 255. Then in this case, if you want to do histogram stretching, then how will you do? Hello.
Yes, sir.
Yes, so see here the histogram of this image is like this. Okay,
Yes, sir.
now in the left hand side portion is representing this black values, and right hand side portion is
Yes, sir.
representing something which is in sky. Now you want
Yes,
to
sir.
see, like if you want to enhance the contrast in this image. So generally when you apply this min max scaling or contrast stretching, then what you do, you take the minimum value, maximum value, and you make it to 0 and 255. But here values are already at 0, and here also 220 or 230. But I can just stretch it to here only, but this will not change in that case. So image will remain same as it is. Getting my point?
Yes, sir.
So in this case, if I want to do contrast stretching, I can do it for any one particular part. If I can do it for this blacker part, or I can do it for sky part. So either land part or sky part. If I want to see the clouds, then I can focus on this particular side of histogram. If I want to see the land features, I have to focus on this side. So basically, let's say I want to focus on this length side. So what I will give my boundary will become 0 to 50, and then I will stretch this 0 to 50 from 0 to 255. Then this particular will become into stretched into entire part. So I am just
Yes.
stretching this portion of the image, not the entire portion, but just this portion of the image. And if you stretch it, then you can see now. After stretching, you can see the image before and after. So now you are able to differentiate between the road also. You can see here something different is there, here something different is there, here the surface is changing, here both side the grass or trees are there, here these poles are there. Otherwise it all looks same only, but now we are able to distinguish it properly. And similarly, if you want to now see the clouds, then this will become black, but clouds will come. But here see, information of clouds is not at all coming. So like that you can remove the clouds. Got my point?
And so basically this technique you applied here,
So I
just
applied this
contrast.
contrast stretching only, but here this two types of bimodal distributions are there. So you have to focus which portion you want to see, whether you want to see
Yes.
this particular bimodal part or this particular part. So if you are interested in land features, so see these are the land features which are with the black values. So if you are interested over here, then you have to focus on the left hand side of the histogram. Whereas if you are interested in
And to
sky, then your range will minimum will become 100, maximum will become 220, and then this 100 and 220 will become from 0 to 255.
and to do this technique, like we have to write this coding.
In coding, I did same only, like what we solved in question today in class. Same thing I did. So I considered the minimum value, maximum value, and that formula which we have solved the question. So 80 to 150 converting into 0 to 255, I used the same formula. I applied that formula to entire image. So the a minus b into 255 divided by the values and addition of the minimum value. Same thing. Okay.
Yes.
So I mean this is not difficult. I mean what we have solved in just one line, that is same thing. And then there is another code which is on filters. I think the time is over, but I will just show this the last output of it. So here I have applied the two filters, Sobel filter and Laplacian filter. So you can see now properly that Sobel filter it detects the edges properly in this plane image. Whereas this Laplacian is just differentiating between plane and the nearby feature airplane. It's just showing that something is there, not the exact boundary detection, just magnitude detection that something is there, not the exact detection of the boundary. I don't know. Yeah. Can you say it here?
Yes.
Okay, so this one is like Sobel is will take more time compared to Laplacian, but ultimately both have their advantage and disadvantage. So this also like now I have used the same filter. Now in this code they have used this CV2 CV64F filter. So now if you are not aware of that, what does that filter mean, then search that thing. So if you go to this library of OpenCV, then you will get an idea that which kind of Laplacian filter they are using. So see, they are using the same filter which we discussed in the today's class. So 0, 1, 0, 1 minus 4, 1, 0, 1, 0. So instead of what we used is 0 minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. They have considered the
Yes.
negative signs. Similarly, sober and the Sachar derivatives are also there. So if you go to this codes or documentations of these libraries, then you will get to know that which kind of kernels they are using. So this is for Sobel filter. If you go, the dx, dy is there, point minus 1 is there, and then these are the different kernels which they are using. So in Sobel, they will use this kind of filters when they want to detect X and Y. So these are the Sobel and Sobel filters for X and Y. So all libraries are built on this very simple, complex, like simple kernel multiplications only, but it's associated multiple mathematics with it. Based on that, it is doing all those things. Okay.
Yes.
So if you just write a code in Gemini or ChatGPT or Perplexity or any other AI, that write down a Python code to do this, so apply Sobel filter or average filter or mean filter, and you just come up with the code and just run that code. It will give you idea in understanding the code or what is happening in the back, and just explore the libraries. So you will get to know what is happening mathematically behind the what you are doing.
Yes.
Okay. Okay, so with that, I will stop sharing my screen. Any questions?
No, sir. Thank you so much, sir.
So now this class will become more interesting. So next week we are having further more on image processing, where we will see this PCA, image classifications, types of image classifications, and some kind of ML also will go into that. So yeah, let's see you on the next class. Till that, have a nice day. Enjoy. Bye
Sir,
bye.
hello, sir.
Yeah.
Sir, can I ask like a personal question?
Yes, yes, you can go ahead.